Addressing mode specifies a rule for interpreting or modifying the address field of the instruction. Excited to know more? Let's see the types of addressing modes. The implied addressing mode is also known as the implicit addressing mode. In this mode, the operand is specified in the instruction itself. The data is 8 bits or 16 bits long, and the data is a part of the instruction. In the immediate addressing mode, we specify the operand in the instruction itself. In simpler words, instead of an address field, the immediate mode instruction consists of an operand field. The advantage of immediate addressing mode is that no memory reference other than the instruction fetch is required to obtain the operand, thus saving one memory or cache cycle in the instruction cycle. In immediate addressing mode, operand is specified in the instruction itself. Since address is equal to 500, the operand 500 is loaded into the AC. In the direct address mode, the address part of the instruction is equal to the effective address. The operand would reside in memory, and the address here is given directly by the instruction's address field. No additional calculations are required to work out effective address. In direct addressing mode, the given address is the address of the operand which is to be loaded. Since address is equal to 500, 500 is the address of the operand, which is the effective address. So, the operand to be loaded into the AC is 800. In the indirect addressing mode, the instruction contains the address of the location where the target address is stored. So in this way, it is indirectly storing the address of the target location in another memory location. It is slower than the direct addressing mode and requires 2 memory references. In the indirect addressing mode, the given address is the pointer to the address of the operand which is to be loaded. Since address is equal to 500, 500 is the pointer to the address of the operand. The effective address, that is the address of the operand to be loaded into the AC, is 800. So, the value 300 is loaded into the AC. In the register direct addressing mode, the operand is contained in a register set. The address field of the instruction refers to the CPU register that contains the operand. No reference to memory is required to fetch the operand. In the register direct addressing mode, operands are in the registers that reside within the CPU. In our given example, the register R1 contains 400, so the operand 400 is loaded into the AC. In the register indirect addressing mode, the address field of the instruction refers to a CPU register that contains the effective address of the operand. Only one reference to memory is required to fetch the operand. In register indirect addressing mode, the selected register contains the address of the operand rather than the operand itself. In our example, the register R1 contains 400, so the effective address which contains the operand is 400. So the value 700 is loaded into the AC. In the indexed addressing mode, effective address of the operand is obtained by adding the content of indexed register with the address part of the instruction. So, the content of indexed register plus address part of the instruction gives the effective address. So as already discussed, in indexed addressing mode, the content of the indexed register is added to the address part of the instruction to obtain the effective address. So here effective address is equal to the indexed register XR plus address part. XR is 100 and address part is 500. These two are added together to get 600, which is our effective address. So the value 900 is loaded into the AC. In the base indexed addressing mode, effective address of the operand is obtained by adding the content of base register with the content of indexed register. So content of base register plus content of indexed register gives effective address. As discussed before, in base indexed addressing mode, the content of an indexed register is added to the content of a base register to obtain the effective address. So effective address is equal to index register XR plus base register BX. XR is equal to 100 and BX is equal to 300. These two are added together to get 400, which is our effective address. So 700 is loaded into the AC. In relative addressing mode, the effective address of the operand is obtained by adding the content of program counter with the address part of the instruction. So content of program counter plus address part of the instruction gives the effective address. So as discussed earlier, in relative addressing mode, the content of PC is added to address part of the instruction. Our next instruction is in the address 202. So our PC value is equal to 202. So now effective address is equal to PC plus address part. PC is equal to 202 and address part is equal to 500, which gives 702, which is our effective address. So the value 325 is loaded into AC. In the auto increment addressing mode, effective address of the operand is equal to content of the register. After accessing the operand, the content of the register is automatically incremented by the step size D. D depends on the size of the operand accessed. Only one reference to memory is required to fetch the operand. The auto increment addressing mode is similar to register indirect mode, except that the register is incremented after its value is used to access memory. In our example, the register R1 is equal to 400. So the effective address of the operand is 400. So the value 700 is loaded to AC and the register R1 is incremented to 401. In the auto decrement addressing mode, effective address of the operand is equal to content of register minus step size. First, the content of the register is decremented by the step size D. Here, D depends on the size of the operand accessed. After decrementing, the operand is read. Only one reference to memory is required to fetch the operand. The auto decrement addressing mode is similar to register indirect mode, except that the register is decremented before its value is used to access memory. In our example, the register R1 is equal to 400. So this value is first decremented to 399. 399 is our effective address. So the value 450 is loaded into AC. Looks like we covered all the given addressing modes. Congratulations! Thank you!